there may be some question sometime that they will ask you that which equation it is. Okay, so to check the equation, I will give you the general partial differential equation. So in general partial differential equation, suppose u is depending upon x and y. So we can have some term of u double x means del u by del 2u by del x square plus twice b into uxy plus c into uyy, that is equal to some function can be of x, it can be of y, it can be of ux also, uy also, or uxy both. Okay, this is known as general equation. If I want to see this equation in the differential form, you can write del 2u by del x square plus twice b del 2u by del x del y, like this we will write it, plus c del 2u by del y square is equal to f x y ux uy u. Okay, so this is this equation. So here x and y are two independent variables. Okay, so these are two independent variables. They can be different also. So this y can be replaced by t also. So then x and t will be two independent variables. So your equation will be ux x, ux t, u t t, f will be x t ux ut u, like this. Understood? So it can be there. Means in place of y, you can take this also. Okay, so here type of curve they will make, this equation will make. Okay, defining condition is what, that we will write here, and after that what is example of that. Okay, number one, type of curve for which we are having the equation, suppose it is hyperbolic. Hyperbolic. Here defining condition, that condition is given by seeing these coefficients. So if AC minus B square is less than 0, so then your equation will give you hyperbolic path. Okay, and example of such equation is wave equation. Number second, parabolic path. So for that, this condition of these will be AC minus B square should be equal to 0. And example of such equation is heat equation. Similarly, third kind is the elliptical path. Condition of that is AC minus B square will be greater than 0. This will be a example is Laplace equation. Okay, so note down this, and these conditions you must remember. Okay, because with that you can understand that which type of equation it is. So you can declare that it is a wave equation or heat equation or Laplace equation. Note down this.
Sir.
Okay, so I will give you one equation. You have to check it. Check the given equation. A square u double x equal to utt. So this equation you have to check. Okay. So now comparing this with the general form, uxx means a and uyy means it will give you c, but you have to take it on left hand side. Then you have to consider. So it is a square uxx minus utt is equal to 0. Okay. So comparing with the standard equation, general partial differential equation. So here a will be a square, c will be minus 1. Okay, and here b is what? 0, because no xt term is there. So hence ac minus b square is equal to a square into minus 1 and minus 0, means it is minus of a square. So minus of a square means it is less than 0. So less than 0, which condition it is following? It is a wave equation, and we have seen that we have used it, so we know it very well. Okay, so it means our test is okay. So given equation is wave equation. Okay, one more question I will give you, same kind. Check the given equation uxx plus uyy is equal to 0. So in place of t here y is there, so no problem. So here a will be what? 1. B is also b is 0 because b is the uxy term, and c is equal to 1. So ac minus b square will be 1 into 1 minus 0 is equal to 1. So this is equal to 1 means 1 is greater than this. So it is a elliptical, and elliptical means it is a Laplace equation. Which is greater than 0. Hence, given equation is Laplace equation which shows elliptical path. Okay, so note down this. Like this, we can recognize any equation. After today, only 2 more classes will be there. So let us see how much we can finish. So this will be finished today only. Tomorrow we can take, first we will take Laplace, and after that, whatever time left, we will start with Fourier. Or anything else you want, means probability or some vector.
Fourier only.
Fourier, okay.
Or Laplace.
Laplace also, no? Laplace is small, this will be finished. It's just you have to learn how to solve. Actually, in Laplace direct formula are there that you have to remember. Okay, but how to solve the problems which are coming in exam, that will be my main point of view. Okay, so that we will discuss.
Sir,
Yes.
what about that elementary probability theory? Can
No, actually time is not there. Probability theory I could do, but this subject was given to others, na. So time.
yes, sir, can you just send us some notes about that?
Yeah,
What?
no problem. I will give.
Thank you, sir.
Done.
Yes, sir.
Okay, so today we will start heat equation. So heat equation, it is of kind the equation of the form c square uxx equal to ut. So this is one dimensional heat equation. Here t value is positive. Okay, if you want to check the dimension, it is simple. Uxx is it will be if you want to check dimensions, so uxx equals to ut by c square. So this implied uxx is del 2u by del x square equal to del u by del t into 1 by c square. So here dimension of u you leave like this because it gives you the heat, or this is the it is giving you the temperature profile. It will give you the temperature profile. In wave equation you have seen that u is the replica of your displacement. Understood? Displacement depending upon position and time, that was the u. But here in heat equation uxt means it is temperature at different position and time. So here del to u by del x square, only I will write this L square. U I will left like this. So here also u will be left like this, and this is time. Okay, time is second. One by L t minus one and whole square of that. So u to u cancel. So this will be L square also, and t to the power del u by del t. This is t. Where is c? Okay, you do one thing. C square L square
Sir, T by L square will come.
uh,
1 by C is in the RHS. So T by L square will come dimension.
1 by c square now.
Yeah, C square will come 1 T by L square.
So it is wrong now. Wait, we will verify it like this. C square into it will be 1 by L square. Okay,
Yes, sir.
that will be equal to del u by del t is 1 by t Only this much.
Yes, sir.
Del. So C will be C square will be L square T to the power minus 1, but it should be T to the power minus 2. Okay. So it can be possible only when it is UTT. And if it is UTT, so then it will be T square. Then it will become T to the power minus 2 and C will become L to the power minus 1. Okay, and which is 2 means velocity. This is the velocity LT minus 1. So it should be UTT. If it is UTT, whether it will follow that, I think now it will become a wave equation. AC minus B square. A square UXX equals to UTT. This has become a wave equation now. But I want heat equation. So heat equation AC minus B square should be equal to 0. And how I can get B? For the B there should be term, this term should be there, no? So for that term, it can be UXT. Suppose UXT is there. Suppose it is UXX C square equals to UXT. So then B value is minus 1 and A value is C square and C value will be 0. So then AC minus once say AC minus B square. So C is already 0 here. So it will be minus of or minus of 1, which is less than 0. So then it will become a not the heat equation, it will become a Laplace equation. So that also we cannot take.
Sir, on Google it is saying that thermal diffusivity unit is L square by T.
L square by T?
Sir, in the equation it's not C square, instead of that it's K. That's what was written. So then it will become L square by T, unit of thermal diffusivity.
Okay, if you take this, so okay, C you cannot use here. A you have to take here, okay?
And UTT is not there, only
UTT is not there, so it will become T only. So that will become a heat equation now. So here the dimension of A it will become UT by A. Leave it. This is like this. So dimension of A we can find out. So dimension of A will be here. This is 1 by L square into it is 1 by T U to U cancel. So dimension of A will be L square by T. Okay. So what they have told it? Thermal diffusivity, na?
Yes, sir.
Okay. So you can note down this, and this will be my heat equation. Okay. So method to solve the heat equation will be similar. How to solve the heat equation? We will apply the same method by variable separable here. Put uxt equal to xx into tt. It means xt. So you put it here in equation number 1. If you put it here, it will become a into uxx, means del 2 divided by del x square. So here it will be x only, because t will be constant here. It will come outside, and that will be equal to del u by del t. So here x will be constant. It will be del by del t of t. Okay. Now to get the variable separable, what I will do? I will divide the whole equation. Divide the whole equation by xt. Divide both sides by xt. So it will become a by x, del 2x by del x square equal to 1 by t del t by del t. Okay. So it now it is purely x. Now one more thing we have to do. This a I will not keep here. I will keep it here, because this is, it will give you a standard format of solution, and in every book a standard format of solution is like this only, that this a is here only. So we have to keep it here, and no problem in that, because this is a independent and it is purely function of x. This is also independent, purely function of t. So this can be possible only when it will be equal to some constant. Suppose we take it here minus lambda square, say. So this is our constant. Okay. So from here we can make 2 ODE, and those ODE will be solved. Note down this.
Yes, sir.
Okay. So we can have 2 ordinary differential equations. One will be 1 by x del 2x by del x square equal to minus lambda square. So it will become, x will be multiplied with this. It will become del 2x by del x square plus lambda square x equal to 0. So here we can write it d square plus lambda square into x equal to 0. So this will work as fd. Okay. So what you can do, auxiliary equation is fd equal to 0. So d square plus lambda square equal to 0. So d will be plus minus pi lambda. So this I lambda will give you the solution. So X answer will be because this is imaginary now, so it will be e to the power ax alpha x, alpha is 0 here, then a cos lambda x plus b sin lambda x. So this is the solution for x. Similarly, we can take second ODE. So that will be 1 upon 80 del t by del t. 1 upon 80 del t by del t will be equal to minus lambda square. So here del t by del t will be minus lambda square a t. That will come on left hand side. So it will become del t by del t plus lambda square a t. Okay. So that will be equal to 0. So here this equation will give you ft. Ft will be del by del t plus a lambda square this is capital T. T will be out equal to 0. So this will be working as FD. What is happening? Okay. So auxiliary equation will be FD equal to 0 means your D plus A lambda square equal to 0. Sorry. Actually, you can integrate it here. You can integrate it directly. It is means variable separable here you can do. That will be 1 by t del t will be equal to minus lambda square a into del t. Okay, so this del t can be converted to dt. 1 by t dt will be minus lambda square a into dt. So now you can integrate it both sides. So it will become ln t. Ln t will be equal to minus lambda square a into t. So here t can be equal to e to the power minus lambda square a t and plus some constant will be there. Okay, so that constant I can write here also. That is the c constant. So this is my value. Okay, that integral constant can be adjusted here. So I'm writing it c. So a, b, c, there are 3 constants right now. Understood? So you can note down it. Actually, this is first order ordinary differential equation. Understood? So for that you have to solve it by variable separable method only. So that putting fd equal to 0, that comes under second order differential equation, and we have done it here, but it is not applicable here. Understood? Note down this.
Confirm.
Okay, so now it is with me and x is also with me. Hence, uxt will be x into t. So x value is already a cos lambda t plus b sin lambda t. So sorry, x should be there, no? Yes, x is there. This is the function of x. Lambda x into this t portion. T portion is c into e to the power minus lambda square at. Now you tell me, this c I can multiply with a, this c I can multiply with b. So those will be constants only. Understood? Just for remembering what you do, here you take a dash b dash. Don't take a dash b dash. Just take a1 b1. a1 b1. So these are a1 b1. Finally, when a1 is multiplied with c, it will become a. That you can write. This will be another constant. So it will be a cos lambda x, b sin lambda x into e to the power minus lambda square at. So this will be the solution for heat equation, and we will always remember this equation. Whenever the question start, we will start from here and we will check what is the value of a in that equation, and that can be put here. Okay, so this will be our final solution for that. Now let us take one question. Means we have to find out these constants a, b. Understood? So to find out that, because it is like a Fourier series only. In Fourier series also we find the coefficient a and bn. So that we will learn here. So here the question can be given. Consider a bar whose ends are capped at 0 degree centigrade. Okay, so actually this will give me the boundary conditions. You can check it here. Okay, so this is a bar. Ends of this bar, this end and this end, both are kept at 0 degree centigrade. So this is the heat. Actually what I told you, that uxt is what? Here uxt is heat profile. Don't say it heat. You can say that this is the temperature profile, temperature. Okay. It is your temperature profile, which is depending upon x and t. So here at this point x is equal to 0. At this point x is equal to L. Suppose road length is L. Okay. It is insulated laterally. Okay. Means no extra heat will be given. Insulated laterally. So whatever the heat is there, it is inside the system only, and that will remain here only. But both the ends, this is the condition, that both the ends will always be kept at x equal t temperature equal to 0 degree. It means what? Your u at, I will repeat. It means what? Boundary conditions are that u, value of temperature. So it is a temperature profile. So value of temperature at 0 at any time. At any time you can check. If it is at 0 means it is an end. At the end the value of temperature is 0. And one more condition is there, that value of temperature at x equal to L. At any time you can check, that is also equal to 0. So these are the two different conditions. Now this condition will give you, with this condition you can find out that your x0, because this condition will give me x0 into tt will be equal to 0. This implies your x0 will be 0. So this is your actual boundary condition. And from this you will get, sorry, xl into t is equal to 0. So this will imply that, because these are the boundary condition especially made for position. So here xl is also 0. So this is your second condition. So these two conditions I will apply and I will find out the coefficient. Okay, note down this. So these are the boundary condition given, and question is what here? Find uxt. So this you have to find. This is my question. So now in such type of problem, directly you have to start from here. Directly you have to start from here, because solution of such equation is known as this. Uxt will be a cos lambda x b sin lambda x e to the power minus lambda square at.
Sir.
Okay, so applying first boundary condition. Or you put the heading. Okay, sorry. This is the solution. Okay, solution of heat equation. You can say that given rod form a heat equation. Okay, for which solution can be written as uxt is equal to a cos lambda x. This you can remember directly, b sin lambda x. And these are different solution for heat equation, for wave equation, and for Laplace equation. Okay, so these three will be there. So these three solution you can remember: a cos lambda x b sin lambda x into e to the power minus lambda square at. Okay, so actually this portion is your x portion, this portion is your t portion. U equal to x t we have put there. Okay, so now you can apply the boundary condition. Boundary condition 1. So boundary condition 1 is what? X naught is equal to 0. So here x portion is this. So in that only you have to put. So a cos 0 plus b sine 0 is equal to 0. Now a cos 0 is 1, so a is equal to 1. So a is equal to 1 means, so you can say that hence xx. What will be xx? What will be this portion? In that a is 0, so only this much is left. So xx will be b sine lambda x. This is the meaning of that. Now you can apply the second boundary condition. What is that? xl equal to 0. So in this xx you put x equal to L, so it will become b sine lambda L, because a is already 0. So that term I will not take. Only this much I will take. B sine lambda L will be equal to 0, and that can be written as, now here because sine lambda L will be 0, b cannot be 0. If b is 0, then whole function will be 0. So that we cannot take, because a is already 0. If you are taking b also 0, so then whole function will be 0. That can never be possible. So only sine lambda L can be 0. So this implies sine lambda L is 0, and that we can write sine n pi. Now comparing on both sides, lambda L will be n pi, and this implies lambda will be n pi by L. Okay, so this lambda value I will put here, so then I will get the this xx value. So xx value will be sine n pi by L, because entry of n is there. So entry, so these coefficients also will be different. Means this coefficient is only for one sine value, but once I am putting here n value, so it has become a series. For that series, b also will make a series, so that we can use bn. In place of b, we can write bn. Okay. So this thing implies, what is your xx? Xx will become bn sine n pi x by L. So this is the value of xx. Note down this.
Done, sir.
Okay. Hence, uxt will be summation. Now it will become in the form of summation, because it has given me the series. Summation n equal to, you can put 0 to infinity bn sine n pi x by L into e to the power minus, now you have to put lambda value here also. Here you can check, this was lambda square. So lambda square means n square pi square by L square, that you have to add. So it will become minus n square pi square by L square into at is also there. Okay, so this will become the final equation if these are the two boundary conditions given. Okay, now I told you some more boundary condition can be given. So you might have seen yesterday we have taken, if it is ux0, we have taken a function fx. If it is u0t, so then we have taken a function, sorry, utx0. So then we have taken a function gx. So this this gx, actually this is del u by del t. So yesterday we have seen, because this was a displacement, so del u by del t will give you the velocity. So it was the initial velocity. So like this, here also we can have the initial condition. Okay, so here also we can have the initial condition if initial condition is given as ut x0. So function we can take, but name will be different. Here it will not be velocity, it will not be initial velocity, but it can be a initial condition definitely. So this condition will be denoted by gx only, but you never name it initial velocity, just you give it initial condition. So this is your initial condition. Okay, so if you are applying this initial condition, so gx will be what? So gx will be, now in this equation you put t equal to 0. Understood? So that will become, but one more thing, first you have to differentiate it. Understood? Because it is ut x0. So first I have to find ut, then only I can find gx. Here ut equal to, or you can write it ut xt you find first. Ut xt will be equal to del u by del t, and this ut you have to use complete xt. So you now you differentiate it. So here which part is having t, that only will be differentiated, rest all will be same. Summation n equal to 0 to infinity bn sin n by x by l, it will be same. Now differentiate this, it will become e to the power minus n square pi square at divided by l square into minus of n square pi square a by l square. This will be the differentiation. Now in that you can put x equal to t, sorry, t equal to 0 at t equal to 0 ut x0, that will be known as gx, and that will be how much? So this whole term will be e to the power 0, e to the power 0 is 1, so only this much is left, minus of n square, or minus also let it be with that only, it will be summation n equal to 0 to infinity bn into this coefficient I will write minus n square pi square a by l square into sine n pi x by l. Now here I can apply now Fourier series method. So how to find out this bn? Just multiply on both the side with this value and then integrate. So that method we will apply. Note down this.
Sir, u of x0 is f of x. That we have to apply first or after this?
Anytime. Here we are applying this first, then that will be applied after. No problem in that. Means both are separate methods, na? Both are separate equation, separate condition. You can apply anyone anytime.
Yes, sir.
Done? So here what you have to do? For Fourier series method. multiply both sides by sin n pi x by L and integrate. So this side it will become integral 0 to L gx dx will be equal to this side, this whole coefficient will come out. It will become bn into minus n square pi square a by L square into integral 0 to L sin square n pi x by L dx. Okay, now this integral we have done so many times. What is the answer of that? Can anybody tell? L by 2. So from here bn can be find out. So in the exam gx will be given, so bn you have to find out. So bn will be this L square to L will cancel. So it will be 2L by minus of 2L by n square pi a into integral gx 0 to L dx. So this will be the value of bn you can find out. So here if gx is given, then also you can find out the value of bn because an is already 0. If fx 0 is if fx is also given, then also you can find out the value of b1, this bn. Okay, so that also we will see. Note down this.
Answer.
Okay. So next you can write if initial condition at t equal to 0 ux0 equal to fx, that was utx0 initial one, that was equal to gx. It is simply ux0 equal to fx is given. So you can apply it directly. uxt was how much? uxt was how much? A cos lambda x plus b sin lambda x. Sorry, in bn you have to apply now. Up to here we have come. Bn sin, in place of lambda it will be n pi x. Bn sin n pi x by L into e to the power minus lambda square means n square pi square by L square into, it was, what was that? E to the power n square pi square a t by L square, no? Now in this you have to put t equal to 0. and this is summation also, n equal to 0 to infinity. So this will become at t equal to 0, so it will become ux0, that will become summation n equal to 0 to infinity bn. This will become e to the power 0, that is 1, so bn sine n pi x by l. So now by Fourier series method, multiply on both. Okay, so this is equal to fx now. Multiply both sides by sine n pi x by l. So then and integrate. So it will be integral 0 to L fx sine n pi x by L dx will be equal to integral Vn 0 to L. It will become sine square n pi x by L dx. Again, this thing will give me L by 2. So answer will be Bn into L by 2. And simply, so this method is more simple than the earlier one. So simply you can find that Bn is equal to twice of 0 to L fx sine n pi x by L dx. So this will be the formula for finding out the Bn. If fx is given, then also you can find out this Bn. If gx is given, then also you can find out the Bn value. Note down this.
Then, sir.
This also note down, then we will take one question.
So that will be 2 by L, right?
Yes.
Sir, one doubt, sir, in the previous g of x, we multiplied with sine n pi x by L, but in the final answer, sir, can you check once the previous page?
What?
Sir, with the g of x, we multiplied the sine n pi x by, but sir, I'm having doubt. What happened?
G.
Yes, sir.
Sorry,
Yes,
sorry, sorry. Here, no, yes, yes. Yes, it should be. Yes, correct it. Okay, thank you.
Thanks,
Here.
sir.
Okay. So question is a bar.
Sir, just one doubt.
Yes.
So in this heat equation also, can we use that D'Alembert formula or something that yesterday's class to find u of x comma l or like that?
No, no, no.
Is
That
it
was there only.
only wave equation can only be used, right?
Yes, yes, yes.
Okay, sir.
This was the D'Alembert formula, no? So this is only for wave equation.
Okay, sir.
Okay, so a bar is kept because here you will see that solution is different from there. Okay, so everything is different. So you cannot apply it. So a bar is kept like this is a bar and the ends of bar. These are the two ends of bar. This end is also kept at 0 degree centigrade temperature. This end is also kept at 0 degree centigrade temperature. Okay, so it means this is the same problem what we have done, and this is also laterally insulated. Means whatever the energy here, that will have diffusion inside only. Extra energy will not be given, extra heat will not be given by the side. Okay, so it is laterally insulated. And one more thing they have given, that here x value is 0, here x value is 80 centimeter. So these are the position given. So here x value 80 centimeter means the length of this will be how much? 80 centimeter. So this is L value. Understood? So in our formula, L value also have been given. And one more thing is they have given that ux0 is equal to 100 sine pi x by 80. So it means what? Ultimately they have given the fx. Okay, and they are asking what is uxt. So this you have to find out. Understood? And one more thing they have given, A is equal to K by sigma rho is equal to 1.158 for copper. So this value is also given. Okay. Now, suppose this is my first question, and second question they have asked, how long will it take for the maximum temperature? Suppose this rod is at its maximum temperature. So how long will it take to become the 50 degree centigrade temperature? It is not talking about the ants, it is talking inside material. So how long will it take for the maximum temperature of bar drop down to 50 degree centigrade temperature? So that is also a question. So these are two questions and these are the conditions given, and ultimately value of A they have given in numerical value. So everything you can apply. Okay, note down this.
Done, sir.
Okay. So UXT, what you have to take here? Heat equation general solution you have to take. And where is that? That formula you must remember. This is the general formula for many times we have used it. So this will be our general formula. This you have to remember. This one. No. This one. Okay. So every time we are using it. So this formula is our general formula for the heat equation. So we will start from there. By general solution, you can say general solution of heat equation. So what is that? Uxt is equal to summation n equal to 0 to infinity bn sin n pi x by L, because a was already 0. So this term into e to the power minus n square pi square, because lambda value also we have put n square pi square divided by L square into a t. Okay. So this was our general formula. Now here what they have given condition? They have given ux0. It means t you have to put 0. At t equal to 0, ux0 will become summation n equal to 0 to infinity bn sin n pi x by L. So these are the exam problems only, not exam problem. Now you can learn it, how to do it. Okay, and so simple it is. If you remember this formula for heat equation especially, this formula you have to apply. For wave equation also you have to apply the wave equation solution formula, and for Laplace equation you have to apply Laplace equation solution formula. So these three you must know. Okay, so I have made a synopsis for this also, and I have put all the formula in that. So just remind me when it is finished, I will send you. So bn into sin n pi x by L into this e to the power 0 is 1 only. So only this much is left. Now this ux0 left hand side, this is already given in the question. So that can be put directly. So this implies 100 sin pi x by 80. Now because from the question you can see that L is equal to 80 from given road. From given road you can find out that L is equal to 80 centimeter. So that we also can put. So in place of this you can put it 80. So it has become 80. So now this 100 sin pi x by 80 will be summation n equal to 0 to infinity bn sin n pi x by 80. Now what you have to do? You have to compare on both sides. Now how I can find out this left hand side? So you can write 100 sin pi x by 80. So on right hand side, which term it will be? Here if you put n equal to 1, so then it will become sin pi x by 80. So then this will be b1. So only this term is this. So b1 sin pi x by 80, and you can get it by put n equal to 1. So now comparing on both sides, this implies b1 is equal to 100. Okay, and rest all value, bn value, rest all bn value are 0. So only this value is applicable here because it is already given in the question. Okay, so now you can get the, again you can put this b1 value here and n value 1 only you have to put here. So then your complete solution will be there. Hence uxt will be summation n equal to 0 to infinity bn. So in place of bn, because n you have to put 1, it will become b1 sine pi x by l into e to the power n you have to put 1, so it will become minus pi square 80 divided by l square. L square means 80 whole square. Okay. So this will be your answer. Now again one more thing, because they have given the value of a also. In the question, value of a is 1.158. So that also I can put. So this implies uxt is equal to, in place of, actually it will not be now summation, because value of n is single now. Value of n is single, so you can, it is not a series now, you can remove it. So value of b1 is 100 into sine pi x by 80. Here also you write 80 into e to the power minus, this is 80 e to the power minus pi square into 1.158 divided by 80 square, 6400 into t. Okay, so this value will be, so can anybody solve this? How much it will be? Okay, you note down it, I will solve it.
Sir,
Yes.
if that f of x is not sine x, or if it is cos x or another, we have to use the integration Fourier method. Is it like that?
No. We want to find uxt only. B1 already we have find out, no?
Yes,
No,
sir,
no.
because he applied the boundary condition.
Yeah, boundary condition I have applied, but here directly I can find out, na? From the series I can compare. So many method we can apply. So this method is simple. You just compare both the side, which term it will be. Because left hand side it is sine pi x by 80. So how I can get sine pi x by 80 on right hand side? Only single term, when n is equal to 1, I can get this. So it will be simple.
So when they are not matching, we have to do that.
Yeah. If many terms are there, and for that only we have to find, so that formula can be applied.
Finally got it. I was looking for a job for the past 2 months. I have like
It is 0.0017. So this value I am telling, this value. So this will become 100 sine pi x by 80 into e to the power minus 0.001785 t. So this will be your final answer. Okay, note down this. So what is this UXT actually? It is a temperature. Simply it is the temperature. Now we have to solve the second portion. In second portion, they have told that how much time it will take for the maximum temperature of the bar to become 50 degrees centigrade temperature. So tell me from this equation, what will be my maximum temperature?
100.
100 into e to the power this one, but at t equal to 0 it will be e to the power 0, so only 100 will be the temperature. Understood? But as the time passes, because sine pi x should be maximum for that, sine pi x by 80 maximum value is 1 only, so that we can write. Okay, so B portion I am solving for maximum temperature sine pi x by 80 will reach equal to 1. Understood? That is UXT. Maximum value will be 100 into e to the power minus 0.001785 T. Actually, for maximum temperature at time T. Understood? Means time I am varying. So at time 10 second, 15 second like this, if I am taking that time, for that maximum temperature will be 100 into this much. But if I am asking that exact pinpoint maximum temperature, that's it. So for that you have to take t equal to 0, so that will be 100. But at any time maximum temperature, you can say like this. For maximum temperature at any time t, maximum temperature at any time t, then you have to multiply e to the power minus this, means t function also will be there. Understood? Now it will become, suppose after time t, it becomes 50 degree centigrade. So we can write 50 will be equal to 100 e to the power minus 0.001785 t. That will be the answer. So this will become 1 by 2 will be equal to, or okay, e to the power minus 0.001785 t, and this implies e to the power, you can make it plus 0.001785 t will be equal to 2. So taking antilog on this, on both sides, so it will become 0.001785 t will be equal to ln2. And what is the value of ln2? 0.693. Hence time will be 0.693 divided by 0.001785, and that value will be 388 seconds. So like this you can find out. Note down this.
Done, sir.
Okay, so just 5-minute test for you. I am giving you the same type of question and you have to find out the time. Okay, so this is question number 2. In the above problem, okay, so rest all problem is same. In the above problem, if initial condition ux0 is equal to 100 sine 3 pi x by 80. So initial condition given as ux0 is equal to 100 sine 3 pi x by 80. So this is given. Okay. Find B portion. So B portion means that time you have to find when the maximum temperature will come to this 100. Sorry, 50. Can you think?
We have to take B3.
Yes. And B3 will also be 100. So it means everything is same for the B portion. Now you find A portion. Or B portion is same, just you have to find A portion, that you can make the question. Tell me what should be the answer. A portion means uxt you have to find. Simple ux0 ux t equal to summation n equal to 0 to find 0 to infinity bn sine n pi x by 80 into e to the power 0. It will become when I am taking it 0. Understood? And this value we will keep at 100 sine 3 pi x by 80. So it means here when you take n equal to 3 at n equal to 3, then only you will get it. It will be sine 3 pi x by 80 will be equal to B3 sine 3 pi x by 80. So this implies B3 is equal to 100. Okay. So that time also you will get the same equation. So UXT will be summation any no here also will not be summation because only one term has come. B3 is 100 sine 3 pi x by 80 into e to the power minus 0.001785t.
Sir,
Yes.
in exponent there is n square, so 9 will come in the exponential.
Okay. Yes, that will be the difference. Definitely. So here n square pi square by L square. L square is 80 square only. So it will become 9. Means it will be 9 times of that. So you can write it 9 times of 0.001785. So this will be that. Okay. So that's why. So A portion will also be different. Understood? So you find the this is the A portion. So B portion also will be left different. So you find the B portion now. So for the B portion, because this has to become 1. Okay. For maximum temperature at any time t. So U maximum xt will be 100 into e to the power minus 9 into 0.001785 into t. Okay. So suppose after time t it will become 50 degrees centigrade. So 50 will be 100 e to the power minus 9 into 0.001785 into t. So like this we will do the everything. So here t will be finally 0.693 divided by 9 into 0.001785. So whatever the answer was, so it will be divide 388 by 9, then you will get the answer.
Forty-three point four.
43 point second. Okay, so this much will be the answer. So like this you can solve it. Okay, so if you want to note down, you can note down quickly. If you want to check these now, so Arfkin book I have used for this.
So what's the name?
Arfkin. But everything is written so much detail now, so means you will be confused. So better to be stick to these notes only, because ultimately we have to just go through it, and we have to learn the things. So we have taken the means extract from there, and this is sufficient. Understood? Done?
Yes, sir.
this also you can note down quickly. Then we will go to next problem.
Sorry, sir.
Okay. Question number 3. In the same bar, or leave it, don't take the same bar. In the bar given as below, so this is the bar. So this is a separate question, no link to previous. So here the conditions are same, that initial 0 degree centigrade, this is also 0 degree centigrade, means these are the L points, end points. Here this is x equal to 0, bar length is L, so this is x equal to L point, and this is laterally insulated. Okay, so here initial condition fx is given. Fx is x L minus x. This is two different fx they have given, x for 0 to L by 2, and this L minus x you have to take fx when x is in between L and L by 2. Understood? So from here they have broken it. For this the fx is x, and for this portion fx is L minus x. Okay, so this type of problem also can come. So here formula for profile you have to use same. Okay, you have to find, question is find uxt. Okay, so how to solve such type of problem? Here the temperature profile can be written as uxt equal to summation n equal to 0 to infinity bn sin n pi x by L into e to the power minus n square pi square at by L square. So this was the formula. So this is my equation number 1. So what you need to find? We have to find out this bn value. Understood? So here bn value you have to find, and from that bn value you can find out the this uxt. Okay, so we have used this formula because if fx is given, I will not repeat it. If fx is given by Fourier series method, if fx is given, then now you can see here fx is so difficult that I cannot compare with right hand side. So I cannot come to know that what will be the value of this Bn. Understood? So here fx is, we can write fx is what? If I take the formula, that is n equal to 0 to infinity Bn sine n pi x by L. So this was my fx. Okay. So here, okay, you can check here. This one, this is my fx. So here by Fourier series method, we have multiplied by sine this and we have integrated. So finally we have got this much if fx is given. So I will use this formula directly. So Bn will be 2 by L, 0 to L, fx sine n pi x by L dx. So that I will use directly. So first you note down this page. And if you don't remember this, ultimately you have to remember this only. So what is fx? Fx is ux0. So here you put t equal to 0. So this will become Bn sine n pi x by L. That's it. That is the fx. ux0. You put t equal to 0. ux0 is fx. And if you don't know the direct formula, Fourier series method also. So you can multiply it again. Method you know. Multiply by sine n pi x by L both side and integrate with respect to L. Okay. So no need to go anywhere. No need to, if you don't remember the formula.
Sir,
Okay. So what you can do, sine n pi x fx sine n pi x by L dx, integrate it. That will be equal to integral 0 to L Bn sine square n pi x by L dx. Okay. And this will be value Bn into L by 2. So Bn will be 2 by L integral 0 to L fx sin n pi x dl. So now this fx, how to apply that you must learn. You will get so many problem, such kind of thing. If means for half portion this value is different, this portion this value difference. So my limits will be break. My limits will break into two portion. First limit is 0 to L by 2. Second limit is L by 2 to L. And accordingly that I will use the value of fx. So many times you will find this type of situation. So my limit will break. One limit is 0 to L by 2. In that fx value is what? X. So it will sin n pi x by L dx plus again L by 2 to L. For that, what is this fx value? L minus x into sin n pi x by L into dx. So this you have to integrate now. So by Liverly method you can do the integration. It is by part integration. So it will be x first term as such into integral of second term. Means integral of sine is minus of cos na, and divide by n pi by l. This is into, okay, and then minus of differentiation of first, that is 1, and double integration of this, so that will become minus of sine n pi x by l divided by n pi by l whole square. So this is finished. Okay, so its limit is 0 to l by 2 plus, here you can do l minus x. So l minus x as such into integration of this, that will be cos n pi x by l divided by n pi by l. Done. Now minus of, again it will be minus 1 into sine n pi x, means minus 1, how? Because you minus of differentiation of this with respect to x, that will be minus 1 only. Sine n pi x by l, that is double differentiation, but with that also minus will be there. Divide by n pi by l whole square, and limits of these are l by 2 to l. Like this you can do. Now you can simplify it. 2 by l, you put l by 2 here. Once you put l by 2, n pi l by 2, so it will become minus into l by 2 into this also will go up, it will become l by n pi into cos n pi by 2. Okay, now this minus minus have become plus, so here you can apply l by 2, sine l by 2, it will become sine n pi by 2 okay, so it will become l square by n pi square plus l square by n square pi square into sine n pi by 2. Done. So this is l by 2 portion, and minus, you put n equal to 0, sorry, x equal to 0, so it will become minus minus plus l by, sorry, x is 0 na, so it is, this is totally 0, so leave it. Again here you put x equal to 0, that will be sine 0, sine 0 is 0, so means it is finished, it is finished. Now coming to this portion, here you have to put l minus l, so that term will be 0. Now minus minus is plus, but minus 1 more, so that will be minus. Here you have to put l, x you have to put l, so that will be n by l, n pi x by l is also there, so l to l cancel, so it will become sine n pi. So sine n pi term will also become 0, that also we have to leave. Only l by 2 terms will be there, So if you put here L by 2, so it will become L minus L by 2 is L by 2 into L by n pi into minus of cos n pi L by 2. So cos n pi by 2. Done. Now for this term, minus minus plus. So, and one more minus. So for that, one minus you have already take. So that is 2 plus. So L by L square by n square pi square into sine. In place of x, you have to put L by 2. It will become n by n pi by 2. You can check it. If anything wrong, please tell me. So this 2 by L, if you are separating it, so 2 by L will be with here also. Here also it is 2 by L. Sorry, it will be plus now. Because L by 2 term only is there, so that will be in minus. Minus already there, so minus minus plus. So if you check, this term will be cancelled with this. And these two terms will be added, this one and this one. Note down this. These are procedure we are learning, okay? Otherwise, in the exam, very short calculation will be there.
Yes, sir.
Getting the same answer now. You also can check. So here now you can add this. This is 2 by L, and this term is same. Again, it is 2 by L and this term, so it will become 4 by L. 4 by L into L square by n square pi square into sine n pi by 2. Okay, so this is the value of Bn. So L to L cancel. So answer is Bn is equal to 4L by n square pi square sine n pi by 2. Okay, so put this value in equation 1. Hence, uxt will be this Bn value only I have to replace here in equation 1. So Bn value I will put and rest all will be same. Now you put it. Sine n pi x by L already there, and I will write here sine n pi by 2 and some Bn value. This. So it will become, it is in term of summation n equal to 0 to infinity 4L by n square pi square sine n pi by 2 sine n pi x by L into e to the power minus n square pi square at divided by L square. So here now if I want to write the series, tell me what will become the series? If in terms of series this answer is asked, so what you can do? N equal to 0, 1, 2, 3, 4, 5 up to infinity it is. Understood? N equal to 0, 1, 2, 3. So if you put n equal to 0, the whole term will become 0. If you put n equal to 1, so then it will be existing. Sine pi by 2 is 1, so then it will be existing. If you put n equal to 2, so again it is whole term is 0. So it means even n equal to even will not be feasible. N equal to odd only will be feasible. So if first two term I ask you what are the first two term, so n equal to 1 and n equal to 3 will give you the terms. So it will become 4l by pi square. First term when n equal to 1 is put, it will be sine pi by 2, that is 1. N equal to 1, this is 1. So it will be sine pi x by L into e to the power minus, because n is 1, pi square at by L square. So this is the first term. If I am asking you second term, so for the second term, you will write here 3. If you write here 3, so sine 3 pi by 2. Sine 3 pi by 2. Sine 3 pi by 2 is in which quadrant? 3 pi by 2. In this, here it will be. So in this quadrant, sine is minus. So that's why minus has come. It will be 1 by n square, means 9 sine 3 pi x by L into e to the power minus 9 pi square at by L square and plus dot dot dot. So like this it will be series, because sometime you have reached up to here and in the option they have asked about first two term of the series. So that much skill also you should develop, that you can check it like this. Note down this. And sometime answer can be graphical also. So if answer is graphical, so you can check it like this. This was your function given. So function with x, how the function was changing? From 0 to L by 2. This is L by 2 and this is L. From 0 to L by 2, your function fx is x. So it will run like this. It is x. Now after L by 2 to L, it will be down L minus x. So L minus x line will be this. So this is your function if you want to draw it. Okay, at t equal to 0. So this is your function. Now what is your answer? Your answer is ut. So how to make a graph for that? That also you can take. It is uxt. So this is your uxt, and with x, if I draw it with x at a particular temperature, suppose at t equal to 1 second, so this is initial time only, so just leave this term, exponential term you leave, because t I have put 1, So only it will go as per sine graph. So this graph will be like this, sine graph. It is at t equal to 1 second. If I am increasing the t value, so then it is exponentially decaying. So what that will mix with this sine term and it will reduce. If I am saying that what will be value of u at t equal to suppose 5 second. So at 5 second, this amplitude of this will be reduced. So this will be reduced like this. Okay, shape will be sine only because first term is sine, but due to this, it is negative. It is more negative now, exponentially decaying. So it will become like this. If I am saying you at after 20 second, you tell me. So after 20 second, this will be more reducing and it will be like this. So like this is reducing. So this much skill you should have, that if there are two type of function, so what it will give effect to that, but shape will be that only. With this e to the power exponential decaying, it will reduce the amplitude every time. So for after 20 second, it will be like this. After 5 second, it will be like this. After just idea we should have. So this type of a skill you should have. And many times we can solve the problem up to last, but in the options these are given like these figures. Then we are blank. Okay, so you must learn this type of a skill. Then you can solve the problem. Okay, so note down it. So in this condition, what is this U? U is a temperature. So after 20 seconds, the whole road will have around 0 temperature. It is reaching towards 0 only. So you can say after t second, after t equal to 20 second, road have around or almost or approximately 0 temperature. It has reached near 0. So like this you can convert. Okay, note down this.
That's sir.
Okay, one more question is given. For a insulated bar, so this is the bar given. These are two ends. X equal to 0, x equal to L. The temperature profile find the temperature profile for conditions are given like this. Ux Means this is differentiation with respect to x. 0t is equal to 0 and ux lt is also 0. Okay, so these are the two conditions given. Now ux is what? Ux is del u by del x. So you can say that this is the gradient. And what is ux0 or uxl? Means at the ends, the gradient is 0. Gradient is 0 means value of temperature is not changing. Value of temperature is not changing at the ends. It means what? These two ends are insulated. Because here value of temperature is not changing. Because del u or del x at x equal to L also 0 and del u or del x at x equal to 0 is also 0. So this is the meaning of that. For a insulated bar means at the ends also it is insulated. Here also it is insulated. So for this bar you have to find out the temperature profile. Okay. So how you can do it? You can apply the same formula. We remember it. uxt is a cos lambda x plus b sin lambda x into e to the power minus lambda square a t. Okay, so in that I can put for condition 1, put x equal to 0. Sorry, first you have to put ux because ux 0 2 you have to find now. So ux xt means you have to differentiate it with respect to x. So it will become minus a sin lambda x into lambda and plus b lambda cos lambda x e to the power minus lambda square at. Now here you put x equal to 0. So this will become ux 0t and it is equal to 0 also. So it will become minus, actually this first term will be 0. Only second term will be b lambda into e to the power minus lambda square at. So from here you can find that b coefficient value is 0. So your uxt will be a cos lambda x e to the power minus lambda square at. Okay, so note down this.
Yes, sir.
Okay, in the same equation where you have put x equal to 0, so if you put x equal to L, if you put x equal to L, so then it will become ux lt and that value is also 0. So here you put x equal to L, this will be because b is already 0, so this term I can forget. So it will be minus of a lambda sin lambda L into e to the power minus lambda square at, and that is all equal to 0. So from here, this sine lambda L will become 0, and that you can write sine n pi. This implies lambda L will be n pi and lambda will be n pi by L. So that value you can put, and so your coefficient also will become an. Hence, now you can find from here. This is your final answer. Here you can put b equal to 0 and a will become an, and that will become a series. So uxt will be summation n equal to 0 to infinity an cos, in place of lambda you write n pi x by L, into e to the power minus lambda square n square pi square divided by L square into a t. So this is the answer. Okay, note down this. So up to here, we have solved these problems only for finite bar. For finite bar, the values of an and bn coefficients can be find out by using Fourier series method. Understood? So this we have done already, but for infinite bar, we have to use Fourier transformation. These are two different things. Fourier transformation method. So in Fourier also, you will find two things. One is Fourier series and another is the Fourier transformation. So here Fourier transformation method you have to apply to calculate the coefficients. Okay, and Fourier transformation method, it is lengthy problem, so we will not solve that, but directly I will tell you what formula you have to use. If question comes in the exam, so that direct formula you can utilize and get the answer. That's it. Note down this.
Done, sir.
Okay, so let us take a very long bar. Modeling of very long bars. Means here, there x was between 0 to L, here x is between minus infinity to infinity. So this is our condition. So this is our bar. This side going up to plus infinity, this side going up to minus infinity. Okay, so this is your x-axis. Now here also condition will be given like this: ux0 equal to fx. It will be given. Then you will be asked uxt. Uxt is what? Okay, what is the temperature profile? So here actually the uxt formula, because problem is same, the uxt formula will be same. Just only coefficient I am changing. Coefficient I am changing here. Your coefficient will be like a cos, in place of lambda x I am writing px, plus b sine, in place of lambda x I am writing p, into e to the power minus lambda square at. So it means it is p square at. So the same formula only I am using. Everything is same. Now Fourier transformation you have to apply to find out the uxt. In uxt, actually here totally different method is there. So we are not going in that. Here Fourier transformation method is there. In Erskine book you can find out whole formula, but it will take 4 pages to explain it, and no need of that. Nobody is asking that. So Fourier transformation applied. Okay, and it is very big calculation, so that's why we are not going there. We are just finding out what are the results. Means Fourier transformation applied to find coefficients, and after putting those coefficients, my uxt will be 1 by 2c under root pi t into integral minus infinity to infinity fv. Actually v is function of x only. Understood? So I will tell you, I will explain what is v. So this is also means fx you will convert into fv into e to the power minus x minus v whole square divided by 4c square t dv. Okay, so this formula they got, but you no need to remember this formula also. I will tell you final formula. If such type of problem comes, that final formula you utilize and get the answer. That's it. Note down this. Done?
Yes, sir.
Now, from here you will get a clue. This x minus v divided by 2c root t. Whole square of that it will be, means it will be whole square of what? X minus v by 2c root t. It will be whole square of that. That complete thing you can put equal to z. So you have to put z equal to this much. So from here if you find v, so v value I can find, v value will be 2zc root t or 2c root t into z and plus x plus x. So that will be the value of v. Okay. So you can write it. V is equal to x plus 2c root t into z. So this is the value of v. If I want to replace it, so dv also you have to replace. You have to replace it. Okay. So dv will be, because x is considered here as constant, so it will be 0 for partial. Okay, for partial thing x is considered constant, so it will be just dv will be applicable on dz. So it will be 2c root t into dz. So this dv will be replaced by this. Now yet you check here. So it will be 1 by 2c root pi t into integral minus infinity to infinity. So this will become, in place of v, we will write x plus 2ct, sorry, x plus 2cz into under root t. This will be v into this term of what I can write, e to the power minus z square, and this term will become 2c root t into dz. Understood? Now this 2c root t will be cut from here, so it is only left uxt is equal to 1 by root pi integral minus infinity to infinity f x plus 2cz under root t into e to the power minus z square dz. So only this much actually you can remember. If the bar is infinite, so then this formula only you have to remember. That's it. From here only you will start your problem and you can get the answer for exam purpose. Okay. Now, if in some case, suppose I'm giving you one question that is also net question. This is difficult type question, but because we know, if you know this formula, so then it will become easy. So question is that let fxt be a solution. Sometimes they will confuse you. Actually, they should have given it uxt. Understood? But examiner can't tell you anything. Let fxt be a solution of heat equation. Del f by del t. So in place of u, they are using f. So no problem in that. D del to f by del square in 1D. Okay. Now tell me, what is this equation? This equation is, if suppose I am taking here u, so it is ut equal to, in place of d I have taken a. They have used this diffusivity, so a is also my diffusivity, u double x. So this is the same equation now what we have taken, heat equation. So just symbols they have changed. In place of a they have taken d. Here I am taking, in place of u I am taking f. So this is the same equation only in 1D. The condition at t equal to 0, they have given fx0. There it was ux0, here it is fx0, so no problem in that. So this they have given e to the power minus x square. Here x value is in between minus infinity to infinity. So from here you will get a clue that it is a infinite bar. Otherwise you will not get any clue. So from here you are getting that it is a infinite bar. So here t is also greater than 0. So everything is same, just only difference is that this is a infinite bar and you have to find out fxt. Note down this.
Then, sir.
Okay. So now, so how to solve this? So directly I will use, I told you directly you use this formula, that's it. So here fxt you want to find out, so that will be 1 by root pi integral minus infinity to infinity f x plus 2cz under root t e to the power minus z square into dz. Okay. Now this fx actually this fx was also this fx not only. Okay. So from here I will get this term because given condition, given initial condition, fx0 is equal to e to the power minus x square. Okay. So from there only I have to take this. So f x plus 2cz root t, this complete thing will become e to the power minus x plus 2cz root t whole square into e to the power minus, sorry, this term you take. One second. Hello. but here t is equal to 0 na. So t equal to 0. So that term also one second. This z you have put here. Here x minus v. This will be your fx. Okay, actually why I have to keep it t here, because I need to find this fx t. So t I have to keep here. Okay, but fx function, this function you treat as it is fx, because earlier we have given that this was ux0 and it was fx. So fx we need, so fx we can take from this. So here also you think it like this. So this fx0 is nothing but fx only. So this fx, so whatever here, so that I will keep here. Understood? By the given condition, you can say my fx is this much, e to the power minus x square. So analogy to that, so whatever inside this, because you are finding out the ultimately fxt, so t should be there. So this complete function will be going as per this. Understood? So there fx plus 2cz under root t will be e to the power minus x plus 2cz under root 2 whole square. So this term I have to keep here. Hence fxt will be 1 by under root pi minus infinity to infinity. It will be e to the power minus x plus 2 c z under root t whole square. Okay. And actually one more thing I wanted to tell. In this book now, in this book, in place of, because we have taken a uxx equals to ut, this is our heat equation. But in this book, in place of the a, they have taken c square. So c is not the velocity of light, but this complete c square is the diffusivity. So c is used as per that. So what we will do, because in this question diffusivity is d, and in this book the formula where it is given, they have taken c square in place of d. So this you must remember that at the last c square will be replaced by d. Okay, c square you have to replace by d. So that you must remember. So you use this formula, no problem. Whenever the c square will come, there we will use d, because in the question d is given, diffusivity. So you can use it like this, into e to the power minus z square is dz. Now this is e to the power this, and this is e to the power minus z square. So they will be added up. So it will be 1 by root pi integration minus infinity to infinity e to the power minus, you open this whole, it will be x square plus 4c square z square t. So that also will be minus because minus sign is outside. 4c square z square into t, and plus 4 x c z under root t also will be there. So that also will become minus 4c x z under root t. This is the just opening of this, and minus z square will also come from here. Now it is the complete. Okay, note down this first.
So we have to replace C, the constant.
We will
C.
replace in the last.
Constant.
Okay, so here see here in this integration, this x is considered as constant or non-effective, so that will come out 1 by root pi, because this is integration with respect to dz only. So e to the power minus x square will come out. Now what is left inside? This z square term, this is also z square term, and this is z term. Okay, those only will be available. So it will be e to the power minus z square if I take common. So what it will be there? 4c square t and plus 1. Okay, and minus 4 xc z under root t. This much is left, dz. Okay, now, or you can write it for z, you keep at the last, 4xc under root t into z. Okay, so what you can do, you can write it like this. There is a formula, integral minus infinity to infinity e to the power minus ax square plus bx. So this is the same kind of formula. This is working as a, and z is working as x square. So this is a x square and plus bx. So this whole thing working as b. If you say that this is plus of minus of this, so this whole thing working as b, and this working as a. Okay, so it will be e to the power minus ax square plus bz. Like this you can think, and that will be equal to under root pi by a into e to the power b square by 4a. So here a is equal to 1 plus 4c square t, and b is equal to minus of 4xc root t. Okay, like this you can understand. So just keep it in the original position. Okay, so it will become now this formula we have to use. It is little bit lengthy, but no problem. You will you can practice it once, then you will get the idea. E to the power minus x square into, so this answer will become under root pi by a into, but a also I have to put na, under root pi by 1 plus 4 c square t. This is under root pi by a into e to the power b square. What is b square? Now you can take whole square of this. So that will be b is 4xc under root t. It will be 16 x square c square into t divide by 4a, 4 into 1 plus 4 c square t. Done. So only this much. So now you can replace c square to d as per our question. So it will become 1 by root pi e to the power minus x square into under root of pi by 1 plus 4 dt into e to the power, this will cut 4, it will become 4x square dt divided by 1 plus 4 dt. Only this much, okay? Sorry, x square is also there, no? No. Leave it. Because that I can multiply, na? This e to the power minus x square, it is here. So that I can multiply here. Means it will be added here. So you remove it here from here. You remove it from here because exponential power, na? So this will become minus x square also. So it is the answer. So we can further solve it. Root pi to root pi cancel. So it is 1 by under root 1 plus 4 dt into e to the power. Here, what you can do, you can take LCM, e to the power 4x square dt minus x square minus 4x square dt divide by 1 plus 4 dt. So here also this will cut. So only this much is left. So answer is 1 by under root 1 plus 4 dt into e to the power minus x square by 1 plus 4 dt. So this is your final answer. Note down this.
Done, sir.
Okay, so it is little bit lengthy, but it will give you so much idea. Now next is the Laplace equation. Actually, this Laplace equation is the form of 2D heat equation only. Okay. In 2D heat equation can be written as, actually my heat equation was if you see the diffusivity into U double X equal to UT. This was my heat equation. If because it was in 1D, if you want to have it in 2D, so in place of XX, you have to take YY also. So in 2D, this is in 1D, and D into UXX plus UYY is equal to UT. So this type of equation will be 2D. In 3D, it will be D into UXX plus UYY plus UZZ equal to UT. Okay, so this is the heat equation in 2D. Okay, now consider the steady state condition. Condition of heat equation. So a steady state means with the time it will not change. Steady state condition. So consider the steady state condition of heat equation, that is del by del T tends to 0. So this implies UT equal to 0. Hence, this is suppose equation number 1. Hence, from equation 1, UXX plus UYY will be equal to 0. Okay, and this is known as Laplace equation. So this is your Laplace equation. Okay, your net exam are still there or it is shifted?
Sir, on 20, they are saying admit card will come. So we will know on 20, sir.
On 20, admit card will be coming on 20.
Yes, sir.
20 January.
Yes, sir, 20 January.
But so much restrictions are there, na, for Corona.
Yes, sir. So that is still uncertain.
Okay.
Because they are announced that +1, 10th and +1 classes are still being conducted and exams are still there. Right now, but maybe it will change it.
Okay. Okay, but be prepared, no problem.
But sir, gate exam hall ticket came actually today.
Oh, today it has come. So when it is?
It's on February 12th.
February 12th. Actually, Corona will run through February also. So they must postpone it. But no problem. Be safe, be at home, and continuously prepare. But whoever have taken vaccines now, so for him it is like a flu only. Just a fever will come and it will go. Whoever not taken vaccine, then it is creating the problem. Note down this.
Yes, sir.
Okay. Now to solve such type of equation, again we will put. So this is my equation number 2. We will use the same variable separable method to solve Laplace equation. Put uxy equal to xx yy, because here t is not there, it is xx and yy only, so that u also will depend upon xy. So it means you have to put u equal to xy. So you put here, it will for uxx, y will be constant, it will become y into del 2x over del x square plus here x is constant, del 2y over del y square is equal to 0. So this will be the equation. Now in this equation, what is our next step? You divide by xy whole equation. So what it will become? 1 by x del 2x over del x square is equal to minus of 1 by y del 2y over del y square. This is capital Y. Okay. Now this is independent, this is independent. So both will be equal to some constant. So you can take here lambda square, suppose. So we will get two ordinary differential equations. Okay, one of them is 1 by x del 2x by del x square equal to lambda square. So this implies del 2x by del x square equal to lambda square x. This we will take on left hand side, del 2x by del x square minus lambda square x equal to 0. So here del 2 by del x square minus lambda square x is equal to 0. So this is your FD. So put, because this is second order differential equation, so to get auxiliary equation, put FD equal to 0. So d square minus lambda square equal to 0, d equal to plus minus lambda. So from here x value will be c1 e to the power lambda x plus c2 e to the power lambda x. So like this you will find the x. Note down this. Sorry, minus lambda x.
Then, sir.
Okay, so from second condition, second ODE will be where is that? Minus 1 by y del 2y over del y square equals to lambda square. So it means this whole thing you can take right hand side. It will become del 2y over del y square plus lambda square y is equal to 0. So here del 2 over del y square, this will work as d square plus lambda square into y equal to 0, or you can write d square plus lambda square into y is equal to 0. So this is your FD. So again auxiliary equation, put FD equal to 0. So d square plus lambda square equal to 0. So d equals to plus minus I lambda. So once complex number is there, so your y will be a cos lambda x plus b sin lambda x. So x also you find out, y also you find out, hence uxy will be C1 e to the power lambda x plus C2 e to the power minus lambda x into A cos lambda x plus B sin lambda x. Okay. So this is the solution of Laplace equation. Okay. So now what this solution shows, this also shows you the means same temperature profile. Actually, Laplace is for, especially it is known as for potential. You can say that this is solution of Laplace equation, which shows potential at any point xy. So actually this is 2D now. This is 2D. So you have to see y, you have to see x. In that there will be a region. So that region is inside this xy. So xy point, here it can be, here it can be, here. So what is the value of potential? That will be given by uxy. So it is a potential at any point xy. Okay. So problem of this we will do tomorrow, and you can note it down. And just only one problem we will solve, then it is finished.
Sir, send us that Laplace transform, Fourier transform.
Huh?
Sir, notes for Laplace and Fourier.
No, tomorrow and day after tomorrow, 2 classes are there, no?
Okay, sir.
So Laplace we will discuss what are the problem which come in the exam, and Fourier we will start, but whatever left that I will send. This is done?
Yes, sir.
Okay. So let us stop here.